All right, good day. Still on Math 121, question number 2, 2016-17, 2016-17 exam, question number 2. My question number 2 may not be actually your question number 2, but it's still in that same exam. You find it in another number. So let's solve it. It says if x squared y plus 3y squared equals to 5x, find dy dx. So this question comes from the topic derivative or derivative. That's where it comes from. So we go to that topic, in our course, in the course proper, Math 121, where we treated this topic extensively, derivative for Math 121, that's for 100 level students. Okay, so solution. Now, what you see here is an implicit function. When we say implicit function, that means it's a function in which y is also part of the independent variable. You know, normal explicit function is when y stands on its own. And you say maybe y equals to like x raised to the power of 2 plus 3x minus 5. Something like this is an explicit function because y is explicit, is like external, it's standing on its own, it's not inside the expression. Unlike this one, you see y is part of the expression. Okay, let me give example of an implicit expression. Imagine like saying something like xy squared equals to 2xy plus 1 plus 1. This is an implicit function because y doesn't stand alone. The dependent variable doesn't stand explicitly on its own, it's inside. So this is an implicit function. I'm going to see how we're going to find the y dx of this implicit function. I'm clean this. Okay, so now dy dx or dy dx equals to d dx, that's derivative of this first term here, x squared y plus d dx of this second term here of what 3y squared equals to d dx of 5x. So now I'm going to differentiate this term by term so that you see how it looks like. Let me start with this one here. That's d dx of what x squared y. Now this, you use the product rule to differentiate this. So using product rule, first I'll keep y constant and differentiate x squared. That would be 2x, then plus I keep x squared constant and differentiate y. You differentiate y to give you the y dx. So for this particular term here, to give us what 2xy plus x squared dy dx. Okay, like that. Now we differentiate the second term here, that is d dx of 3y squared. That will be equals to, and if you differentiate it as if you want to differentiate normal x. That's then it should be 2 times 3, 6. That would be 6. y minus 1, that's y raised by 1, 6y. And since you are differentiating y itself, you have to attach the y dx to it. So it will be 6y dy dx. That's how we differentiate that one. And then the last term here, 5x, d dx of 5x. We differentiate that, it will give you 5. So I've finished differentiating for the term. So our final dy dx, our dy dx now will be, the first term was this will be x squared dy dx plus 2xy. See this? Plus 2xy. Now our second term was 6y dy dx plus 6y dy dx, and our equals to 5. Understood? Okay. That's if you bring all of them together. So working with this and this, go to the next page. And this, rewriting that expression, you have x squared dy dx plus 2xy plus 6 dy dx equals to 5. So since we are looking for dy dx, now we are going to collect like terms, bring all the terms that have dy dx on them together, and the ones that doesn't have dy dx, group them in other side. So bring the ones that have dy dx together. So this x squared dy dx plus 6 dy dx, okay, plus 2xy equals to 5. So we factor out dy dx here. So you have x squared plus 6. This should be, what it was 6? It should be 6y, sorry. This is 6y. 6y, sorry. Factor it out, that would be 6y. Y dx now outside plus 2xy equals to 5. So I'm going to make dy dx the subject of the formula here. So I'll take this term to the other side. So you have x squared plus 6y dx equals to 5 minus 2xy. Now dy dx standing alone will now be 5 minus 2xy divided by x squared plus 6y. So this is dy dx. So that's how we differentiate that. So this is the expression that we differentiated. We asked to find dy dx. So if we differentiate this, this is what you are going to get. Get dy dx equals 5 minus 2xy by x squared plus 6y. So that's the answer to that. Thank you.